Several properties of Z transform. Now one property has been left, that is Parseval's relation. So Parseval's relation. Parseval's relation. If the Z transform of a signal x1n is x1z, and Z transform of another signal x2n equal to x2z, then the Parseval's relationship is summation of n equal to minus infinity to infinity x1n into x2n complex conjugate of x2n is equal to 1 by 2 pi j contour integration x1 v into capital X complex conjugate of capital X2 of 1 by v complement conjugate into v inverse dv. So this is the Parseval's relationship, where the contour integration must be lie in the overlap of the regions of convergence of x1 v and x2 complex conjugate of x2 1 by complex conjugate of v, right? So this is the Parseval relationship. Now we will study about inverse Z transform. Now there are several process of inverse Z transform. So inverse Z transform. Inverse Z transform. There are four processes to do inverse Z transform. They are long division method, or power series expansion method. Second, partial fraction expansion method. Partial fraction expansion method. Third one is residue method. Fourth one is convolution method. So there are four basic processes to do inverse Z transform convolution method. Now among these four methods, convolution method is not in your syllabus. So we will study about power series expansion method, partial fraction expansion method, and residue method. Now power series expansion method. Series expansion method. Power series expansion method. We will study it with the help of an example. Okay, suppose we will study it when the ROC mod of Z greater than something. So here in this case, suppose I am taking an example where xz equal to z plus 0.2 divided by z plus 0.5 into z minus 1, and ROC is mod of z greater than 1. So here there are two poles, one is minus 0.5 and another one is 1. So highest pole is 1. So here the ROC is mod of z greater than 1. So the entire sequence after z, inverse z transform will be causal sequence, right? So in this method of transforming inverse z transform, we will get xn. By doing inverse z transform, we will get xn from xz, right? So at first for the causal sequence, at first you have to multiply the denominator portion. So if I multiply this, it will become z square plus 1.5, there is minus 1 and there is 0.5, so minus 0.5 z minus 0.5, right? So this will be the multiplication. Now you have to divide the numerator portion by the denominator, right? So this is z square minus 0.5 z minus 0.5, and here is z plus 0.2. This is the portion. Now at first we multiply it by z to the power minus 1. If I multiply it by z to the power minus 1, then it is become z. Okay, so z minus 0.5 minus 0.5 z inverse, right? So after subtracting this and this, I am subtracting this portion from this, so it will become 0.7. If you add these two numbers, it becomes 0.7, and this is 0.5 z inverse. So from for getting 0.7 from this polynomial, you have to multiply 0.7 z to the power minus 2, right? So it will be 0.7 z to the power minus 2. Here is 0.7 and here will be minus 0.35 z inverse, right? And this portion will be minus 0.35 z to the power minus 2, right? Now if I subtract this portion, this will be cancel out, and the total remaining portion will be 0.85 z inverse, and this is 0.35 z to the power minus 2. Okay, now we have to multiply this portion by 0.85 z to the power minus q. So here is 0.85 z to the power minus q to get this portion. So this will be 0.85 z inverse, right? And this portion will be minus 0.425 z square. This will be z square, right? And this will be minus 425 z cube. So this, after subtracting, this will be cancel out, and this total portion will be 0.775 z to the power minus 2 plus 0.425 z to the power minus 3, right? Now to get this portion, again you have to multiply it by 0.775 z to the power minus 4, right? So it will be z to the power minus 4, and the portion will be 0.775 z square plus minus 0.387. If you multiply with this portion, it becomes 0.387 z to the power minus q minus 0.387 z to the power minus 4, right? Now again if I subtract this portion, this will be cancel out and this will be plus again. Okay, so you have to do up to 3 or you have to do this portion up to 3 or 4 terms, right? Here is 4 terms, 1 2 3 4, right? And it will go further step, but we do not do anything. Okay, so xz will become equal to this result. So z to the power minus 1 plus 0.7 z to the power minus 2 plus 0.85 z to the power minus 3 plus 0.775 z to the power minus 4 plus dot dot and so on, right? So if we equate this portion by the to the formula of Z transform, that is n equal to minus infinity to infinity xn into z to the power minus n. So we will get x0, sorry, this is not x0, because when n equal to 1 then we will get x to z to the power minus 1, right? If n equal to 1 then we will get z to the power minus 1, so it will be x1. So x1 will be equal to, what is the coefficient of z to the power minus 1? That is 1, so 1. And for n equal to 2 it becomes z to the power minus 2, so this portion is matching with this portion, and x2 is matching with 0.7, so x2 will be 0.7, right? Again when n equal to 3, this portion is matching with this z to the power minus 3, but here will be x3, so x3 is matching with 0.85, so x3 will be equal to 0.85. again x4 will be equal to 0.775 and so on. Okay, so these are the result of this inverse Z transform, right? So this is for causal sequence. Again I am taking an example of non-causal sequence. Okay, so suppose this is B, xz equal to z by z minus 3, z minus 4, and ROC is mod of z less than 3, right? So in this case you have to multiply the denominator section, so it will be z square minus 7z plus 12, right? This portion. Now since here the poles are 3 and 4, and 3 in ROC mod of z less than 3, so 3 is the lowest value of the the two poles, among the two poles. Okay, so this is basically the result will become a anti-causal or non-causal signal, right? So for the non-causal sequence, the division process is a little bit different. Okay, so the division process will be like this: 12 minus 7z plus z square. You have to shuffle the denominator portion like this way. Okay, and z is divided by this polynomial. Okay, so to get z from this dividend, you have to multiply what quantity? Z by 12 to this number. Okay, so multiply z by 12, it will get you will get z minus 7 by 12 z square, okay, plus zq to the power 12, right? Now subtract it, so it is cancel out. Here is 7 by 12 z square, and this is minus zq by 12, right? So to get 7 by 12 z square, again we will multiply by 7 by 144, right? 7 by 144 into z square. So we will get 7 by 12 z square minus this, so 49 by 144, right, z cube, and this portion will be 7 by 144 z to the power 4, right? So if I subtract this portion from the upper portion, this portion will be cancel out, and this portion will be equal to 37 z cube by 144, right? And this will be equal to 7 z to the power 4 by 144. Again we are multiplying by to get this value from this portion, we have to multiplying it by 37 by 1728, right? So it will be 37 by 1728 z cube. Here is z cube, so here will be z cube. So 37 z cube by 144, multiply this 2, so it will become minus 259 z to the power 4 by 1728, and this portion will be 37 by 1728 z to the power 5, right? So this is z to the power 5. Now again subtract this portion, it will become, this portion will be cancel out, and the subtraction will be something, this will be something, okay? So here I am getting 3 terms, so just left out, and so from here we can get xz equal to z by 12 plus 7 by 144 z square, okay, plus 37 by 1728 z cube, and so on, right? So this is also to be equated from the formula n equal to minus infinity to infinity xn into z to the power minus n, okay? So from here, when will I get z from this? When n equal to minus 1, so x of minus 1 will be equal to what? 1 by 12, right? Because the coefficient of z is 1 by 12, so this will be equated to this portion, so x of minus 1 will be 1 by 12. Again x of minus 2 will be equal to, the coefficient is 7 by 144, right? And x of minus 3 will be equal to 37 by 1728, and so on, and so on, right? So this is the inverse Z transform of this quantity, that is given by xz equal to this portion. Now the second process is partial fraction expansion method. So number 2 is partial fraction expansion method, right? So partial fraction expansion method, this is very simple method, okay? Now let us taking an example to do this, okay? Suppose xz is given by z into z square minus 4z plus 5 divided by z minus 3, z minus 1 and z minus 2. Okay, but there are varieties of ROCs. In number 1, ROC is 2 less than mod of z less than 3, right? In number 2, ROC is given by mod of z greater than 3. In number 3, ROC is given by mod of z less than 1. Okay, so there are varieties of ROCs. So you have to solve, you have to do inverse Z transform of this quantity xz equal to this portion. Okay, so before doing the partial fraction, you have to first evaluate it. From here we can write that xz by z equal to z square minus 4z plus 5 divided by the factors are z minus 1, z minus 2 and z minus 3, right? So in partial fraction expansion method, it can be assumed like this way: a by z minus 1 plus b by z minus 2 plus c by z minus 3, say. Okay, so here a, b, c are basically arbitrary constant. You have to find out the values of those constant, right? So what is the shortcut method to evaluate the value of a, b and c? That is, a can be found by this from this quantity. A will be equal to z square minus 4z plus 5. So z square minus 4z plus 5 divided by, okay, the factor containing z minus 1 that can be omitted, okay, and the remaining portion is z minus 2 and z minus 3. So it will be z minus 2 into z minus 3 at z equal to 1. Why z equal to 1? Because from here, if we put z minus 1 equal to 0, then we will get z equal to 1, right? So that value will be that value has to be putted here. Okay, so if we put z equal to 1, it will become 1 minus 4 plus 5 divided by 1 minus 2, 1 minus 3, right? So this will become so this will become 6 minus 4, so that is 2, and here is minus 1 and minus 2, so that is also 2. So 2 by 2 is 1 basically. So b will be equal to z square minus 4z plus 5 divided by z minus 1 and z minus 3. Here b is for z minus 2, b is for the factor z minus 2. So z minus 2 portion will be omitted from this quantity, and and put the value z equal to 2. So here will be 4 minus 8 plus 5 divided by 2 minus 1, 2 minus 3, right? So this value will be equal to 9 minus 8, so that is equal to 1, and here is 1 and minus 1, so the value will be equal to minus 1, right? And c will be equal to z square minus 4z plus 5 divided by z minus 1 into z minus 2. Okay, so put the value here z equal to 3. So if we put 3, it will be 3 square minus 4 into 3 plus 5 divided by 3 minus 1, and this is 3 minus 2. Okay, so this will be 9 plus 5, that is 14, minus 6, 12. 14 minus 12, that is 2, divided by, this portion will be 2 into 1, so 2 by 2 equal to 1. So C will be equal to 1. So from this we can write that xz by z will be equal to 1 by z minus 1, right, minus 1 by z minus 2 plus 1 by z minus 3. So from here we can write xz will be equal to, if you multiply z, so z by z minus 1 minus z by z minus 2 plus z by z minus 3, right? Now in the first case ROC is 2 less than, here 2 less than mod of z less than 3, right? So 2 less than mod of z less than 3. In this case, from this ROC, mod of z basically greater than 2 and mod of z less than 3. Here the poles are 1, 2 and 3. So z less than 3, that means this portion will be non-causal, right? And z greater than 2, so this portion will be causal as well as this portion will be causal. Okay, so for this portion, what will be xn? Xn will be equal to, since this is causal, so form is a to the power n into un, right? Now what is a here? That is 1. So 1 to the power n into un. This is the form of a infinite duration causal sequence, right? Now for this portion, what is a? That is 2. Okay, z by z minus a, this is the form. So a is 2 here, so minus 2 to the power n into un. And for this portion this is the non-causal section, right? So here is here b is equal to 3, right? For non-causal section z by z minus b, but what was the sequence? That is that was minus b to the power n into u of minus n minus 1. So b is here minus, b is 3, right? So that will be minus 3 to the power n into u of, minus n minus 1, this. So this will be the complete inverse z transform of the given sequence for the condition of ROC is 2 less than mod z less than 3, right? So here is 1 to the power n, that means 1, so it will be even, right? Now number 2, ROC for number 2, ROC was mod of z greater than 3, right? Mod of z, ROC was mod of z greater than 3. So here will be mod of z greater than 3. Now see here, poles are 1, 2 and 3, and here is the ROC mod of z greater than 3, right? ROC is mod of z greater than, so 3 is the highest pole among the 3 poles. Okay, so all the terms will be causal in this case. So xn will be equal to 1 to the power n into un. This will be 2 to the power n into un, and for this portion 3 to the power n into un. So for the ROC mod of z greater than 3, xn will be equal to this portion, right? Now in condition 3, ROC was mod of z less than 1, right? So mod of z less than 1. For this case, 1 is basically the lowest value among 3 poles. Okay, lowest value of the poles among 3 poles. Okay, so all the terms will be non-causal in this case. So in that case, xn will be written in this format, minus 1 to the power n into u of minus n minus 1. Okay, Now for this portion, minus 2 to the power n u of minus n minus 1, and for this portion, oh sorry, this there is a minus sign here. Okay, so minus minus becomes plus. Okay, and for this portion it is become 3 to the power n into u of minus n minus 1, right? So it can be written like this way. So all for all the three terms, u of minus n minus 1 is common term. This is minus 1. Okay, this is 2 to the power n, and this is 3 to the power n. So 2 to the power n minus 3 to the power n minus 1 into u of minus n minus 1. So this is the inverse Z transform for the condition 3, right? So this is the partial fraction expansion method. This is very important thing. Okay, you have to practice several times this portion. Now the last is the residue method. Do you know about contour integration? You have learned about contour integration, right, in your maths portion, mathematics. Okay, so there was a residue theorem, but in this case you have to just remember the formula. Okay, in this case you have to just remember the formula of residue method. The formula is xn equal to 1 by 2 pi j contour integration xz into z to the power n minus 1 into dz. So this is the formula of residue method, right? So from here we can write sum of residue of xz into z to the power n minus 1 at poles of xz into z to the power n minus 1 within C. Okay, so this has to be done. Now let us take an example to do residue method. Okay, now let us take an example to do residue method. Okay, so here I am taking xz equal to z plus 1 by z plus 0.2 into z minus 1, right, where the ROC is mod of z greater than 1. Okay, now you have to take two conditions. One is for n less than 0, and another one is for n greater than equal to 0. Okay, for n less than 0 we know for if we get the values of xn for n less than 0, then the sequence will be non-causal sequence, right? And if we get the values of xn for n greater than equal to 0, then the sequence will be causal sequence. So in this case we have to check both the portion, right? So at first, for n less than 0, say for n equal to minus 1, we get xn equal to what? 1 by 2 pi j. This is the formula, contour integration xz into z to the power minus n minus 1, right, dz. So this is the formula. So this will be equal to sum of residue of xz into z to the power n minus 1 at poles of same within C. Okay, so for n equal to -1, it will be sum of residue of xz into z to the power -2 at poles of same within C. Okay, so it will be equal to sum of residue of z plus 1 into z square z plus 0.2 into z minus 1 at poles z equal to 0, 1 and minus 0.2, right? So this person. So this will be equal to so the value of this will be basically so at poles z equal to 0, this portion will be omitted and put z equal to 0, and for this z equal to 1. Okay, so this portion will be omitted, and the remaining portion, for the remaining portion put z equal to minus 0.2 because this. Okay, this, and for z equal to 1, this portion will be omitted and put z equal to sorry, this will be equal to 1. So this is 1 1 1. Okay, so the total portion will be equal to 0. Now test for n equal to 0. For n equal to 0, because here the ROC mod of z greater than 1, you have to search for n equal to 0. So for n equal to 0, the value of xn will be equal to xn equal to sum of residue of this portion xz into z to the power minus 1 at poles of same within C, because here I am putting n equal to 0, so n is 0 and this will be equal to z to the power minus 1, right? So sum of residue of this z plus 1 z to the minus 1 z plus 0.2 into z minus 1 at poles of same within C. So this will be equal to sum of residue of this portion will be equal to z plus 1 by z into z plus 0.2 into z minus 1 at poles z equal to 0, minus 0.2 and 1. So this will be equal to z plus 1. So for this pole 0, the residue will be z plus 1 by z plus 0.2 and z minus 1 at z equal to 0, and for this pole the residue will be z plus 1 divided by z into z minus 1 at z equal to minus 0.2, right? And for this pole the residue will be z plus 1 z into z plus find 2 and put the value z equal to 1. So all the three terms will be sum up. Okay, so if we put here 0 0 plus 1 by 0 plus 0.2 into 0 minus 1, for this portion this will be minus 0.2 plus 1 divided by minus 0.2 minus 0.2 minus 1. For this portion this will be 1 plus 1 divided by 1 into 1 plus 0.2. So this portion will be minus 5 plus 10 by 3 plus 5 by 3. So this will be equal to 0. Okay, now for n greater than equal to 1. Okay, so here we can see that for x0 for n equal to 0, that means x0 is equal to 0 here. Okay, now for n greater than equal to 0, xn equal to sum of residue of z plus 1 into z to the power n minus 1 divided by z plus 0.2 into z minus 1 at poles z equal to minus 0.2 and z equal to 1, right? So residue at a pole z equal to minus 0.2, that is z plus 1 into z to the power n minus 1 divided by z minus 1 at pole z equal to minus 0.2 plus z plus 1 into z to the power n minus 1 divided by at pole z equal to 1, so the residue will be z into z plus 0.2 at z equal to 1. Okay, so if you put this portion minus 0.2 plus 1 into minus 0.2 to the power n minus 1 divided by minus 0.2 minus 1, and this portion will be 1 plus 1 into 1 to the power n minus 1. Okay, here 1 plus 0.2. So this portion will be, this is basically 0.8 divided by minus 1.2, right, into minus 0.2 to the power n minus 1, and this portion will be 2 divided by this 1.2, right? So this portion will be minus 2.3 to the power minus 0.2 to the power n minus 1, and this will be 5 by 3. Okay, so from here we can say that for all the values of n that is less than 1, okay, xn equal to 0, and for n greater than equal to 1 we are getting xn equal to this. So xn will be equal to this will be 5 by 3 minus 2 by 3 minus 0.2 to the power n minus 1 whole into u of n minus 1. So this is the inverse z transform using residue formula, right? So you have to practice several maths relating to residue theorem and partial fraction expansion method and also power series expansion method. Okay, so thank you.